The popcorn is ready.
Oh, great. Thanks. Boy, you forgot the light.
Sorry.
I got it.
Movie time! Alright, I got it. Alright, I'm pressing play.
Newton's first law states that an object at rest will remain at rest unless acted upon by an unbalanced force, and an object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Rube Goldberg devices use many different objects and techniques to act as the unbalanced force to either change the direction or speed of the original object. An example of this law would be when the unbalanced marble rolls into the set of cases, knocking them into the bottle and setting off the pendulum. The DVD cases never would have moved had they not been acted upon by the unbalanced force, i.e. the marble. Newton's third law of motion states that every action has an equal and opposite reaction. In this particular Rube Goldberg, this law is shown when the marble goes down the zigzag track. As the marble maneuvers its way down the zigzag track, it hits a wall and bounces back. This is the wall's equal and opposite reaction to the marble, which then falls through the hole and onto the track in the opposite direction. The constant slant of the track, the lack of friction between the slick marble and the posterboard track, and the gravitational force keeps the ball constantly moving until it hits the equal and opposite force of the wall stopper at the end of the track. Another example of the effects of Newton's third law is the water bottle attached to the string at the end of the device. In this situation, the stand below the water jug is acted upon by the unbalanced force that is a large ball that is connected to the pendulum. When the stand is hit by the ball, the large water jug is knocked off, pulling the string attached to the light switch, causing the light to be turned off. Before the ball attached to the pendulum is acted upon by an unbalanced force, it is at an angle of 25 degrees with the vertical axis. The length of the string is 30.5 inches, or 0.775 meters, and the acceleration due to gravity is 9.8 meters per second squared in the negative direction. Using the formula, tension equals 2 pi times the square root of length over gravity, and velocity equals the square root of 2 times gravity times length times 1 minus cosine theta, we can find both the period and the velocity of the system. So we have tension equals 2 pi times the square root of 0.775 meters divided by 9.8 meters per second squared. This gives us 2 pi times 0.28. Tension equals 1.77 newtons. Next we have velocity. Velocity equals the square root of 2 times 9.8 meters per second squared times 0.775 meters times 1 minus the cosine of 25 degrees. Velocity equals the square root of 1.42. From there we can find that velocity equals 1.19 meters per second. Once the ball leaves a zigzag, it heads down a track and into a funnel. The marble rolls along the sides of the funnel, working its way towards the center until it falls in the hole. Using the equation, velocity equals the square root of gravity times radius over tangent theta, we can solve for the marble's velocity as it leaves the funnel. So we have velocity equals the square root of 9.8 meters per second squared times 0.015 meters divided by tangent of 60 degrees. The velocity equals 2.9 meters per second.